everyone. Today we are going to learn 5.4, the method of undetermined coefficients. Okay, so let's take a look. So we have constant coefficient equation. So I am writing equation shortcut like that, right? Okay, so A, B, C are constant coefficient, right? And then we have e to the alpha x, right? So we had the last time linear and quadratic. Remember? Okay, today we have new stuff. So right hand side, we have e to the alpha x. Okay, then last section, what we did. So we did that. We found general solution, which is consist of particular solution and complementary solution, right? Complementary equation, complementary solution. Yeah. Okay. So previously we have complementary solution was general solution, right? The form was the same, right? Okay. Then we have a new stuff, new concept here, undetermined coefficient. Okay. So let's make that right-hand side as g of x. G of x. Okay, then we have a g of x here. Okay, so right-hand side, we're gonna say the guess. If we have a constant, that's constant A. And by the way, look, the letter is not consistent because I was using y of t. Your homework, most of the time, they're using t, right? But then lecture note using x, right? So here, we're guessing right-hand side, which is a particular solution, yeah? Then we are using x because we express in terms of x, yeah? Okay, we can change any letter. We know that, right? Okay, now right-hand side, from the equation, right? So constants, easily to guess. Linear, we did that previously. Quadratic form looks like this. Cubic function, so we have x cubed. Second, first, 0 power, right? Decreasing order for x. So we have a cubic for g of x, yeah? Okay, now brand new, if we have the constant A and then E to the, we call this is a beta, right? Read beta in Greek letter, Greek alphabet, right? So beta X, then we can guess the particular solution as constant, which is the coefficient same, E to the beta X, or we can have A times X, constant coefficient times X, e to the beta X, or we can express AX squared e to the beta X. So I added the blue one. It depends on the complementary equation, complementary solution, okay? So if we have this form, in right-hand side, then this is a better right-hand side, yeah? Then we can guess the form, particular solution, okay? So I say that depends on the complementary solution, right? So we have one example like this. So I'm gonna more explain to you later on, okay? Okay, now everything is the same. So left-hand side? No, right-hand side. Sorry about that. Sorry. Crazy. So right-hand side, right? Right-hand side from the equation, right? Yeah. Okay. Now we have everything's the same. There will be A cosine beta x plus B sine beta x. Yeah. So what right hand side form has? We can guess particular solution like this. Look, single A cosine beta x, B cosine beta x, or A cosine beta x, B sine beta x. Yeah. Then those right hand side form we can guess as particular solution like that. Okay. Okay. Now nth degree polynomial for right hand side, we can just using descending order. Okay. Okay. Let's do example so we understand what this means, right? Okay. We have y double prime minus 7, y prime plus 12y equal to 4 times e to e to the 2x. Yeah. So look, e to the sum x, right? With the coefficient. So what is this? Yeah. So we can guess a e to the beta x. Yeah. Okay. So in that case, beta will be 2, right? Beta equal to 2. So we are using a e to the 2x. Make sense? Okay. Now let's find a complementary solution. Yeah. To change the r squared minus 7r plus 12 equal to 0. Because complementary equation associated with the homogeneous equation to find such R, right? Okay, let's do that. For complement y sub c, yeah? Okay, so we have r squared minus 7r plus 12 equal to 0. Okay, can we factor out? Yes. So r times r and 4 times 3, right? Which one is bigger? 4 is bigger or is it smaller, right? Ooh, it's a plus, right? Sorry. So negative negative make a positive, and then negative 3 plus negative 4 make negative 7, right? Okay, good. So we can see that r equal to 3, r equal to 4. Yeah. Okay. Now, we can see that there is a two distinct roots, right? So then we can have, would you like go over review? Okay, I have the page, end of a page. Okay, so let's review quickly. So if we have distinct real root, then we can have this form, yeah, general solution. So this one was before when we had complementary solution. So now we're using this one as a complementary solution, right? So this is the form. So we are using the first solution. We are using second solution for this one. In that case, 3 and 4, right? Okay, let's go back. Okay, so that will be two real distinct root will be y equal to c sub 1 e to the r sub 1x plus c sub 2 e to the r sub 2x, yeah? So in that case, r sub 1 equal to 3, r sub 2 equal to 4. So we have y, and the general solution will be complementary solution, right? So we're using that. C sub 1 e to the 3x plus c sub 2 e to the 4x. Yeah. Okay. look, the solution include e to the 3x. The solution include e to the 4x. But then right-hand side, we have e to the 2x. That's why we could use e to the 2x. Otherwise, we cannot use that. Okay, second example like this. So let us do just a simple like that first. Then I'm gonna explain to you about that later, okay? All right. Now, particular solution, we're looking at the right-hand side. So this is for left-hand side for a particular solution. Right-hand side, looking at that. So we guess let me write in y particular solution, e to the 2x, yeah? Derivative drop to e to the 2x. Second derivative drop to, so 4a to the 2x, yeah? Okay, now we have the original problem, right? So we substitute what is the y second prime? We have, so substitute, let me using another page. Okay, so y double prime we have for 4a to the 2x minus 7 y prime to a to the 2x and plus 12y a to the 2x equal to 4a to the 2x, yeah? So last section we did the corresponding, right? So before we do that, let's combine, like distribute, right? More easily to see, right? So for a to the 2x minus 7 times 2, 14, a to the 2x plus 12a to the 2x equal to 4 to the 2x, yeah? Okay, can you combine like term? Yes, we can do that. So 4 minus 14, negative 10 plus 12, which is 2, right? So 2a to the 2x equal to 4 to the 2x. Then they are corresponding. Yeah, okay. So let me push a little bit left. So I can use the space. So that will be 2a equal to 4. Then a will be what? A equal to 2. Yeah. Okay. Very good. Now, that's it. I need to space. Then particular solution will be, what do you have? Particular solution? A to the 2x, and then a equal to 2, so 2e to the 2x. Yeah. Okay, so the general solution for undetermined coefficient, we have y over t, but then we have in terms of x, so I want to use y over x equal to complementary solution plus a particular solution. So complementary, we have C sub 1 like that, right? Copy. And then particular solution. So we get y over x, general solution, y over x equal to c sub 1 e to the 3x plus c sub 2 e to the 4x. Particular solution will be e to the 2x, yeah? So we are done, yeah? Okay, let us do second question. Okay, so we have a second question here. Find the general solution of, this one we get the same, isn't it? So we had the complementary solution will be r equal to 3, r equal to 4, right? Okay, let's just copy from there. So copy. Is it straight? Okay, good. It's straight, right? All right. Now, look, but then looking at the right-hand side, so we have 5 e to the 4x, yeah? Normally, we are using earlier question, right? Am I recording? Make sure, okay. So earlier we had e to the some x, right? So beta x, yeah? We could use that, right? But then in that case, we cannot use that because we had e to the 4x already. So we are using e to the 4x, yeah? That's why we cannot use e to the beta x. So we have to use little bit special one. So I made blue, yeah? We have to add x there. Make sense to you? Otherwise, it's the same form. We cannot get the such a, yeah, a. All right? Because it will be get rid of together, other term. All right? Okay. Now, so we are using insert x. So we guess ax e to the 4x. Make sense to you? This is what I talked earlier, okay? All right, now we had a complementary solution. So let's find particular solution here, right? Okay. Let me put the page. For particular solution, right hand side, right? So we have y. So P particular solution, we are using ax e to the 4x. Okay, now we want to derivative. So product rule, so fg, f prime g plus fg prime. So we will get a f prime, just a e to the 4x plus f ax g prime, so 4 e to the 4x. Yeah. Okay, now we do double prime. So first term, we have 4 a e to the 4x. Yes? Okay, second term, product rule again. So f g, f prime g plus f g prime. Yeah? So we get f prime 4a g e to the 4x plus f 4ax g prime 4 e to the 4x. Oh no, x is on the power. Yeah. Okay, so that will be, let's combine this one, 8, right? So 8a e to the 4x plus 4 times 4, 16. So 16ax e to the 4x. Yeah. Okay, that's double prime. All right, same concept as earlier. So from the original equation, we substitute what is the y second prime, y prime, y, right? Then solve for such a. Copy? Okay, so y double prime, we get 8a e to the 4x plus 16ax e to the 4x minus 7 y prime a e to the 4x plus 4ax e to the 4x, and handwriting is big, right? And plus 12y. I should make a little bit smaller. Yeah. Okay. Then plus 12y is 8x e to the 4x equal to 5e to the 4x. Yeah. All right. So let's combine, distribute and then combine like term. Yeah. Minus 7a to the 4x minus 28ax e to the 4x plus 12ax e to the 4x equal to 5 e to the 4x. Yeah. Okay. Combining like term a e to the x. This one? Oh, this one. Oops. This one? This one? That's it, right? So we have 1a. Oh. Okay, I can use the same color. 1a e to the 4x And this one, this one, this one. Okay, so we get 16 plus minus 28 plus 12. So what do you get this one? AX. So cannot hold on 1 second. Okay, that will be plus 0x 0ax e to the 4x. Yeah. Equal to 5 e to the 4x. Okay, so this one corresponding, right? So that means a equal to 5. We can see that, right? All right. So particular solution, we have this form. So particular solution, and we have ax e to the x power, right? So ax e to the 4x power, right? Okay, then in the case 5, so we have 5x e to the 4x. Okay, then what's the general solution? So we have general solution. So y of x equal to complementary solution and then particular solution. So we have complementary solution will be this, like earlier, right? The previous example. And particular solution we have like that. So we can just rewrite, right? So y of x equal to c sub 1 e to the 3x plus c sub 2 e to the 4x plus 5x e to the 4x. Yeah. So far, so good? Okay, very good. All right, so let us do next one. So we have this equation, and then we want to find the general solution. Yeah. So any sign, the trig function related as a sine cosine, we have a same form, right? So whether single sine, single cosine, or combined with the two terms of sine and cosine, right? So we get this form, we can guess for particular solution, okay? All right, so in that case, beta equal to 3, right? This is the beta. So beta equal to 3, and then A cosine beta x, B sine beta x, yeah? Okay, now, complementary solution. Y sub c, left-hand side, we're looking at that. So r squared minus 5r plus 4 equal to 0, right? Can you factor out? Yes, good. So what is that? -4, -1? Okay, then r equal to 4, r equal to 1, right? Okay, we had experience. The complementary solution will be C sub 1 e to the 4x plus C sub 2 e to the 1x. Yeah, so which is x, right? Okay, now for particular solution, right hand side from the guessing, right? Right hand side. So from the guess, we have A cosine 3x plus B sine 3x. Okay, now derivative. Okay, cosine, negative sine, then times 3, right? So negative 3A sine 3x. And derivative of sine, cosine, and times 3 because there is a beta is a 3, right? So plus 3b cosine 3x. Okay? All right. Double prime. Sine, cosine, derivative of sine, which is cosine, and times 3, right? So negative 9a cosine 3x and derivative of cosine is a negative sine and then times 3, so 9b sine 3x. Yeah. Okay, now we have original one and substitute y second prime, y prime, y, right? Okay, so there will be double prime, negative 9. Let me just copy. Copy. I want to make a parenthesis. No parenthesis. It's up to you. So 5 y prime. Oh, I need to make it a little bit smaller, yeah? Okay, make it smaller. At least one side to make a line up, right? Okay, plus 4. Y. Ooh. Hmm. A cosine 3x plus B sine 3x equal to, what do you have? Negative 1000 sine 3t. Okay, all right. Let's distribute and then combining like term, okay? All right, so negative 9a cosine 3x minus 9b sine 3x, positive 15a sine 3x minus 15 cosine 3x, no space, positive 4a, right? So positive 4a. Okay, hold on one second. I make a mistake, right? So there is a 15b. Yeah. And then positive 4a cosine 3x and positive 4b sine 3x. Yeah. Equal to, sorry, a little bit messy, 1000 sine 3t. Yeah. Okay. Let's combine. So that would be negative 5a cosine 3x and I want to writing here the cosine 3x here, so negative 15b cosine 3x and combining like terms, so negative 5b negative 5b sine 3x and rewriting this one 15a positive 15a sine 3x equal to negative 1000 sine 3x. Yeah. Okay. So cosine 3x. Oh, no. I'm writing for. Okay, so let me add the page here. This one, I need that. Okay, so orange. So that would be negative 5a minus 15b cosine 3x plus negative 5b plus 15a sine 3x equal to negative 1000 sine 3x. Okay? All right. So this one, we don't have any corresponding, right? But we have a sine 3x corresponding. So negative 5b plus 15a equal to 1000, negative 1000 and negative 5a minus 15b equal to 0. Yeah? Let me arrange that. Yeah, so this one equal to that, right? Okay, so negative 5, different color. Negative 5b plus 15a equal to negative 1000 and negative 5a, negative 15b equal to 0, right? 15b. Okay, now then, it's up to you. What do you want to get rid of, right? Let us do times negative 3. Then we get positive 15b plus 15, negative 15a equal to positive 3000, right? And then the bottom one has like that, right? Okay, then, oh, no, hold on 1 second. I have not. 3 times 15, 45. Yeah. Okay, so then, simplify is 0. We have a negative 58 equal to 3000. So what's the A will be then? It's negative, right? Good, 60. Okay, now we can substitute anything. So I think this is more easier. So we have negative 15b minus 5a equal to 0. So negative 15b minus 5a equal to negative 60 equal to 0. What do you get? So negative 15 equal to negative 300. So B equal to, what do we have? 20? Very good. Okay, now, oh, uh, we have a B, right? So let's arrange. We had particular solution. The form is A cosine 3x, B sine 3x. So we will have A equal to negative 60 cosine 3x plus B equal to 20 sine 3x. Yeah. Okay. General solution. So we have y equal to complementary solution plus particular solution, right? So complementary solution, we have like that. Copy. And particular solution. Ooh, sorry. Copy. So we can say that y of x, complementary solution will be c sub 1 e to the 4x plus c sub 2 e to the x, and particular solution will be negative 60 cosine 3x plus 20 sine x, yeah? 3x, sorry, sine 3x. Okay, so one more question, then we are done. Okay, so once again, T4 gas. Yeah. So we have for particular solution, right? So constant A, linear, and then everything. So basically, linear quadratic, we did that last time, right? And then today we have e to the beta x and the single sine beta x, yeah? Then we can guess with combining with cosine and sine, yeah? Okay, good. Once again, if for what is called the general solution earlier, previously, right? But then this will be the complementary solution, yeah? Now, so it will be complementary solution, right? Complementary solution for last section and this section, right? Okay, so we did that two distinct real roots, yeah. And then we did that the last section, right? And we did that this one too, right? Yeah. Okay, why I am doing this one? Because we have the multiple choice. So all together, yeah. Match the differential equation with the particular solution form. Okay, so pretty much we guess, and then we are using the beta. Yeah. Okay. What do you think the first one? First one, we can, this is complementary solution, right? So we can factor out r minus 5, r minus 2. Then looking at the right-hand side, e to the 5t. So we cannot use a e to the 5t because they're using e to the 5t as a solution for complementary, right? So basically, let me write down. So there uh, will be, we have c sub 1 e to the 5t plus c sub 2 e to the 2t, right? So we cannot use a e to the 5t. So we have to use a t e to the 5t. So we have to insert t. Make sense to you? Like a second problem, what we did earlier, right? Okay? Yeah. So let me write down. We can't have e since e to the 5t is a solution is already solution in particular solution. Let me just do, let me make it shorter. Yeah. Okay. So the answer will be AT. C then, right? Answer is C. Clear? Okay. So the second one we have same thing, right? So we have y particular, sorry, oh my gosh, complementary solution. Yeah. Why I'm confused in, yeah, last time too, right? Yeah. Sorry. Complementary solution we have c sub 1 e to the 5t plus c sub 2 e to the 2t, right? Okay, then for particular solution, we can use the a e to the negative 2t. No problem, right? So it will be a. Yeah. So answer A. Yeah, good. Okay, third one. So complementary solution, same. Copy. Okay, look, the right hand side for particular solution, right? We never had this one before. Yeah, but then this is a little bit more complicated, right? So looks like this is a linear form. Okay, let's find out linear form with e to the negative 2t, right? Okay, so there will be, yeah, because we don't have e to the negative 2t as a solution for complementary equation, right? Yeah, so it will be f. So it's a linear form added there, right? So answer will be F. Okay, now let's take a look. So complementary solution, same. But then look, like earlier, number 3, this is also linear form, right? But then we cannot use like a F form, AT plus B, linear form e to the 5t, right? Anyway, we don't have this example there, right? Multiple choice, yeah? Why? Because 5t is already in solution. So we are inserting t like we insert x earlier, right? Okay, so B is the one, has a linear form. Yeah. I'm not sure there is negative or positive, but it's okay. Same linear form, we can treat them. All right, so just insert to the T, right? Yeah. Let me write down. Since e to the 5t is already in a complementary solution, so we can't have linear form at plus b e to the 5t, right? So answer will be insert t, which is b, right? So at plus b, t insert e to the 5t. Make sense? Okay, two more? Okay, so we have this one. So we have repeated solution, right? If we have a repeated solution, then we will get this form c sub 1 plus c sub 2x, right? If we distribute, so we get c sub 1 e to the r sub 1x plus c sub 2 e to the r sub 1x, yeah? Okay. Oh, no, but then we have a repeating, right? So we insert x there, right? Yeah, x, yeah. So we have x there, yeah. Distribute. Don't forget that. Okay, now, so the solution will be complementary solution will be c sub 1 e to the negative 2t plus c sub 2t e to the negative 2t. That's the solution for complement equation, right? Okay, now which one is? Yeah, we can just using simply a e to the 5t because none of them duplicate, right? As a solution. So we are using e. So e is the solution, right? Okay, the last one. In that case, let's take a look. Same thing, we have same solution repeated and same complementary solution there, right? Copy? Okay, then we could use, let me do this way. We could use a e to the negative 2t, right? But then negative 2t is in the solution, in the complementary equation, right? So we have to insert t, right? But then it's already t there too, right? Can you see? That's why we choose a t squared e to the negative 2t. Makes sense to you? Okay, so let me write down e to the negative 2t and t e to the negative 2t are already in solution, right? So we can't have the form a e to the negative 2t or and at e to the negative 2t, right? That's why we choose t squared. So answer will be D. It's the. Okay, thank you for watching. Bye.